Cool. Well, I think we should get going. You shouldn't be punished for others being late, but rather encouraged to be on time. So thank you, everyone being on time. Assignment, yeah. So yeah, it's time to talk about it, right? So to get some stuff done, because we have a moderate amount of time left before the end of the semester. How many weeks do we have left? That's cool. Very different from my previous institutions. There, the students always knew how much time they have to bear with me before they're actually free again. So now I think we have 1 more week, and then you have 2 weeks holiday. Is that correct, or 2 more weeks?
A week and a half holiday. 8 weeks until the exam.
8. Yeah, that's very precise. Yeah, there you go. Didn't expect anything else. So we need to do an assignment before that, right? Before the exam. And eventually we came out with some sort of description, because we wanted to make it reasonably loose and give you reasonably reasonable flexibility for input. So and the idea, what came out of this is the kind of twofold approach. So for your assignment 2, you have 2 options. So either you do what was expected, and you guys have anticipated it. I wonder how many of you have started on it already. Pac-Man 3D. Ta-da. So idea there, you capitalize on what you did and shift it in the 3rd dimension, right? So there's certain aspects you need to change in terms of obviously you have the 3rd dimension, think about views and so on. But we get to that in a second. I will get to it in more detail. And feel free to reuse any code if you opt to do that variant, right? So there's no point starting off from scratch again if you don't need to, unless you of course want to. But even if you don't do, you're probably very efficient re-implementing whatever, conceptually re-implementing whatever you wanted to have done for the 2nd assignment, right? So for the 1st assignment, sorry. The 2nd one is the idea that you get proactive. So you come up with a task that you want to do. I have a few in mind, but a task that would be along the lines of your interest. And the discussion that we had last week, I believe, was that some people are more interested really in the game element, right? So kind of apply it to both of those, or graphics in particular, so more refined graphics elements. And if you have some ideas that require a bit more depth insight, then we probably can sneak that in as part of the lectures as well, right, to complement those interests. Or if you are more into focusing on developing a thorough architecture of your of whatever you want to write, I guess. Those are the various options that we have. More ideas in a second. So those would be the 2 options you have. It's 30% of your grade, and as of now it would be due end of April, so roughly 6 weeks. Does that sound reasonable? Right. So because in May we have an exam, right? So and then apparently we need to know the marks of your internal assessments before we can do the exam. So we can't just do it back to back, unfortunately, because I would have liked that. So you get maximum amount to finish it up, and then you can do the exam, and everything is happy. No, everyone, sorry, but we can't. So we need to do it a bit earlier. That said, if you feel okay, I need more time, I'm kind of a bit loose on that one, because yeah, we'll see how that goes. But 6 weeks, I think, is a decent amount of time to get stuff done. Of course, there's a little more flexibility in the 2nd task. We need to explore that. Before we go to the details, group allocation, same theme as before, right? So there's a dedicated wiki page with group allocations. Note that this time it's a copy of the original one with mild modifications. So the 1st assignment group allocation is still there, but you need to re-add your group allocations. And the reason why you need to re-add it is because I don't know how many people will actually do the 2nd assignment, right? So I originally thought, okay, just copy the group allocations, because many people will stick to the same ones. But you can still refer to the assignment group 1 allocations, copy your stuff from there, so you don't need to reassemble your entries again and then append it down here, and obviously update your repository URL. So that's the boilerplate stuff here. Before I forget it, I just wanted to do it now. But getting to the tasks. So Pac-Man 3D is largely like 2D in terms of its functionality. The main difference is that it's getting technically more refined, in that you need to have a 3D representation of some sort. Walls should have textures as opposed to just being some sort of box as it was in the 2nd one. The rest is pretty much the same. The Pac-Man should be controllable. You have items, the player score, and so on, those kind of things. We have ghosts as well. But the challenges come a bit more down here. So the idea is there. Yeah, so some of those elements have been copied. So if there's inconsistency, it's in favor of the newly added stuff. The idea is there, one of the challenges is, if you decide to do Pac-Man, there needs to be at least one character model that is loaded, right, for using object loader, some sort of object loader, and it should be textures as well. The reason is, that's something you will need to do for the exam, I can tell you outright, so it's probably very worthwhile that everyone has that exposure independent of the choice, right? The more the better, the more complex the better, but at least one of either collectibles, Pac-Man, or the ghosts, yeah.
Is it terribly advanced to implement animation for the Pac-Man character and the ghosts on 3D models?
Well, it's actually a series. Well, if some the answer, short answer, no, it shouldn't be too painful for you, because in practice, some of the models that we talked about, 3D formats, they support animation and some don't. OBJ doesn't out of the box, so it's actually a static, model. But how it usually works is that you have a series of OBJ models, right? Let's say 8 of them to represent a full cycle of animation, for example, for the Pac-Man movement and so on. And then you can just load them dynamically, or load them all and then just exchange them at runtime. So that would be how you would approach that using, for example, the OBJ format. Some other formats have native animation included. Then you just need to specify the timing, right, or time step, and then they will automatically play with the right speed, I guess, right? So that's one of the aspects. Yeah, good point. Perhaps that's probably something we should discuss as well, animation in models. We get to that, so we make that one session. That is not a hard requirement for that one though, right? So the idea is really about object loading primarily. Animations would be nice. That would be along the bonus line of things if we manage that. But it's a good point. Cool. So there needs to be something loaded. If you use other people's models, which is perfectly fine, be explicit about it, right? Just, I didn't write this here yet, I will add this. Be explicit about your sources, where you got them from, right? So because it's easier for us also to, look at we're looking at the models and see how complex they are. That tells us a lot about how, complicated it was to actually implement and use them, right? So, but also just to be creatively inspired by you, because you're usually more resourceful than we are. Because you have the collective manpower of the entire class for that. The character, the concrete model, obviously is not hard to find, right? So if you really don't want to use a Pac-Man character, we found one which we could possibly use. But if you don't want to use one, you can use any other sort of model, right? So as long there's some model element loaded, the more the better. At least one of them. If more, again, there's potential for additional reward. Some basic lighting model. I'm not explicit about what that would be, but you can push the boundaries there, right? So we had the, which kind of lighting models did we have?
Spotlights,
yep.
For example.
Cool, what else?
Directional lights.
Yeah, and what was the cheapest one?
Cheapest one, ambient light.
Yes, right, so ambient light is the no-brainer of lights. So that's obviously super baseline. It would be good to go to one of the, well, Spotlight would probably be the most desirable one, but we want to keep it to some extent at your discretion. I mean, obviously, if you have the full form model in here, including reflection and specular effects, that would be brilliant. So that would be something we would like to see, but obviously you need to think about lighting somehow, right? And we had a bit of discussion whether we require you a lot. I think you should push, you should go for it and actually implement the full form model. But we get to that in a second. That we give you why we give you the flexibility. One problem. What's the problem in Pac-Man 3D? Impossible problem. You think about modeling Pac-Man in 3D. Which question do you need to ask yourself?
First person and third person?
Yeah, exactly. Right, why?
Well, how do you do first person Pac-Man? I can't look over the walls.
That's right. So how do you do that? That's exactly right.
You can.
What?
If you make the camera tall enough to look over.
That's another option.
Maybe.
Cool.
I'll
So,
just do it top down again, but like at the style angles, you can see that it's 3D.
okay. So that's precisely the issue, right? So so our intuition, of course, if there are better suggestions, we're in for it. What's the idea? If you do it first person, meaning you're actually looking, through Pac-Man's perspective, advantage you don't need the model for Pac-Man. Disadvantage you don't see over walls, right? So the idea there was, okay, in this case you need to have still a 2D projection, right, adjacent to your first person view, so you actually know where you are, kind of a navigation pane if you want, right? Yes, and exactly. And you can, again, if you do it, capitalize on the 2D Pac-Man, basically, right? It's just synchronizing the two different representations. So if you, however, choose the, I said something about third person perspective, right? So then you have this benefit that you can watch, see some elements of the scene. So in this case, you wouldn't need to have that. But of course, you need to have a player model of Pac-Man, and you need to deal with camera perspective and so on, right? If you want to push it, of course, that's an option to just be able to switch between those perspectives as well, which would be kind of cool. So then you
rotating your camera around the Pac-Man in a third-person view using your mouse.
Okay.
I imagine that would probably be the easiest one to orient yourself without using a minimap.
If in third-person view?
Yeah.
Yeah.
So you can see over the walls, but you can see the ghosts poking out over the walls. So looking around, you can see where all the ghosts are, but you can't exactly see the layout of the level.
That's the intuition with the third-person one. That you usually slightly elevated, so you have this effect of being able to peek over the walls. So meaning, point is, if you're able to navigate somehow, and you figure out a clever, good way of doing that, perhaps even by having a flexible camera, right? So it may be strictly positioned, or you may even introduce flexibility on the part of the user, then it's perfectly fine, right? So as long as there's a way to play this game somehow, right? As opposed to just, randomly explore the grid and possibly be eaten anyway. So that's one of the challenges to think about. So it would be a design decision you would need to make. In addition to this, there's some optional features where you can and should push it. I think that's the idea. Of course, advanced lighting models. If you go all in, that's definitely worthwhile doing. Switching between perspectives is one of the ideas. The complexity of models is decisive as well, right? So you could have a very simple model that you're loading, which is relatively coarse-grained and so on, or rather more advanced and requires more rendering because there may be material or material information attached and so on. So those would be arguments you can make that you did something on top of the expected. Write your own object loader if you want. If you're terribly keen to do that, that's obviously something we would reward, but not something that's strictly required, because in reality you're most likely using one of the bigger ones, the existing ones, that's perfectly fine as well. So if you have, again, movable camera would be a possible option, or multiple levels, so similar to the stuff we talked about before. But here you see the focus is a bit more on tech and a bit less on gameplay, right? So previously there was more on gameplay elements there. But of course, if you want to increase, fun elements and so on, you can do that as well, or reintroduce sound, as some of you did the last session and so on. Of course, since you're capitalizing on your previous effort, it may probably not get as much of a reward as some of the other features. On the other side, however, for this iteration, irrespective of the choice you make, you will need to use GLFW for implementation. So the ones of you who use SDL have the disadvantage they need to learn GLFW, but they should be able to capitalize on some of the features that they have in SDL, which happens to be sound, for example, that they can possibly reuse. But key is the windowing needs to be done GLFW. It's just because we're looking at the complexity, and it turns out it's just you get a better understanding of the details, the internals, if you use a more basic, meaning GLFW framework. So that's our intuition, so that we're all on the same page, because SDL is easier to learn in the long run. So for anyone who wants to switch eventually, it should be a lot easier to go to the higher level of abstraction as opposed to the lower. So that's why we require it. So that's Pac-Man 3D roughly there. Did I forget anything there? Any question for that option? You can ask later as well, but perhaps there's something ad hoc you have in mind. No. I don't. If something comes out, let me know. It's kind of on top of my head to some extent. So the second one, the curiosity task. I was looking for a name for this thing, and I thought, okay, well, that's the rendering as opposed to gameplay as opposed to blah blah task. No, that doesn't really, sound good. So curiosity is the angle here. The idea is there, do something you like, right? So do something you want to do. So it's not so much something I propose. I have a few ideas in mind. You could do, some scene rendering and so on. But what you want to say, suggest here is say, okay, I want to do in my team the following kind of task. And you just need to ensure that it has certain elements as part of a proposal, right? So your idea needs to consider model loading, lighting, keyboards, interaction, and so on. Basically, all the basic technologies that we learned, because I need you guys to be on par for the exam, right? So we need to have kind of the same experience, right? Even if you're not necessarily building a game, then you still need to have the kind of same background. So the idea here is that you guys propose something and tell me, first of all, what you want to do, surprise, surprise, how it relates to the course, so what you're actually using of the course, right? So as opposed to just using third-party libraries that do everything for you, you need to tell us, okay, that's what we're going to implement. Yeah, the link to the course, what you implement, and why you want to do it, what you expect to learn from it. So, and based on the intention, we can see, first of all, we want you guys to be reflective. Why am I doing this? What do I want to get out of this? And then we need to see whether it actually fits into the course objectives. That's one of the things we need to guarantee as instructors, that you kind of work towards the learning outcomes, which is kind of a formal problem, but we need to put it in somewhere. That's why this one. So if you have an idea, come up to us and we discuss about this. Think about the components it includes, the big picture idea it has, and what you want to do in terms of using external resources, which is fine. You're at liberty to use your own code anyway, but also external libraries. But of course, you try to scout and think about which ones you want to do. If they change over time, so what? That happens. But it would be good to do some initial scouting, that you have an idea what you want to do. One thing is, that's something we need to work on together. If you decide to go down that route, that we need to make it hard enough so it corresponds to 30% of the course internal assessment load, right? So it needs to be kind of fair, right, compared to the Pac-Man task. So we need to scale it up and down. The proposal needs to be in a written form. Yes, we can do informal negotiations, but we need to write it down. The reason is, when we assess it, we need to still have a look. What was promised? What was delivered? Right? That's how it's done in real life, to some extent. And of course, things can change, but then it's we just need to justify why it has, or why you went beyond the proposal. That's also one option, right? So, and this would be sitting in the repository as well. So, yes. So those would be the minimum features you would have. Of course, you should have, unless you really explore them in great depth, you probably need to have additional features on top of that one, that you need to argue why you're using them and how you are using them. So that's the flexibility we give you. So any ideas of what you guys think would be a possible scenario you could do for the curiosity task? And I know there were some objectives which we haven't covered yet that may be of interest there. So we would, depending on the interest, we would introduce those selected as lectures as well. So everyone gets the exposure, but this group benefits, from it as well, because everything else you need to know for the first task is something you should know by now anyway already. So there's not much. You have gotten basically the background to some extent already. So I was thinking that if you want to, for example, represent a scene, right? So animated scene with I don't know, some items such as a traffic situation, for example, that's reasonably complex in an animated form. That would be one possible, thing I could think about. You have model loading elements in there. You have mouse camera interaction with them. You don't necessarily control any of the entities, but you need to be able to navigate over the scene, and you need to play with lighting. So those would be something that could be quite challenging. And you most likely run into performance issues if you have multiple objects of the same kind. So you need to deal with kind of a lot of different issues there already. Would be one thing we had in mind. If subsurface scattering would be still of interest, then we would introduce it as a lecture. Yeah, I need to dig into it myself, in fact, in greater depth, but it will be quite complex. So meaning as soon as you use that word, you most likely hit the 30%. So that's something we need to explore. But here is really flexibility on your part, right? So brainstorm a bit, think about what you want to do, and just let's think about it on Monday. I think there was another idea I had in mind. Hang on. I think I had some other idea. Before I forget it. Yeah, or yeah, if you want to do some procedural modeling, right? So where you, for example, load one model, for example, but place it in a scene that is procedurally generated, right? So some of you mentioned like you want to be more explicit about working with shaders. So it's something that would happen there. You don't explicitly model the terrain and load it, but rather generate it on the fly using the GPU capabilities in the first place. That would be one other angle. Or a sophisticated model loader that considers material appearance or lighting elements as well. So in this case, yeah, so you would integrate all those three elements as well. But again, you need to push the sophistication and tell me why you want to redevelop something that exists already, unless you really make it a lot better. So those would be some directions there. But if something comes up, you can just come up on Monday or even earlier than that. But Monday is probably reasonable, and then we can discuss and see if it matches in terms of complexity, and then go from there. Yeah. So anyway, it's just an offer that we have here, and as I mentioned before, careful. There you go. The technical requirements are quite clear. So OpenGL, C++, GLFW, those are the baseline. Is the baseline functionality you want to use. If you use external libraries like SIMP or Tiny Object Loader and so on, just be explicit about it that you use them. That's fine. It's no harm. Because in the end, realistically, in real life, you most likely use a lot of third-party libraries for functionality. But of course, if you write the object loader yourself, that's cool. If you want to use OpenSDL, as I mentioned before, for some other features, no big deal, no problem at all. Just that the main functionality is done using GLFW. I think, yeah, that should be roughly it. I don't think I forgot anything relevant there. Professionalism, same as before. Code should be good as well. Modular, somewhat documented, or actually documented. Versioning, you guys know how it works. And I made it explicit here. I want to have a README with instructions of, perhaps an overview of your deliverable, what it does, and so on, who the authors are, but also how to run this thing, basically, right? So because this discipline is a tad more involved, so it's not always super obvious how you run your code, right? Some of you just use Visual Studio and hope that everything goes well. There were some advanced moves towards using CMake, so which is obviously desirable. But we probably won't strictly require it because it's technically not graphic, so, and it's not in the course objective, so we can't force you to do that, I guess. But it would obviously be very nice as a feature. Plus, since Jonas provided us with the tutorial, you're actually halfway there anyway. Okay, so since we have this flexibility of 30%, of the entire mark, pretty much defined by you or largely defined by you. We also think about in terms of marking, you want to be able to set the emphasis on what we give you marks for. So the idea is that once you have developed Pac-Man into 2D already, you probably realized, okay, there's arbitrary directions I can go further, right? So in terms of, do I introduce multiple levels? Do I texture my walls? Do I improve my animation? So it's like, it's endless, right? So, or do I work on a better architecture, right? So not look at features so much. And we wanted to respond to that by giving you the choice of weighting or putting a weight on particular aspects of your project. So we will give you the choice of either favoring, saying, okay, I want we put more effort into architecture or framework development. So, like how do you do the shader mapping, for example, in C++? Those kind of aspects that we had seen here in some lectures. So basically, just the code quality in particular, for example, or do we go for game player usability, right? So we have a very smooth experience from a gamer perspective in playing that game, right? So you think about all possible aspects, that the animations are nice, that you get around corners smoothly as opposed to need to kind of get your way around through the grid and so on. So there were certain aspects as well. or if you just go for the aesthetics, that you really put super, a lot of effort into refining graphics and have, material appearance effects, reflection models, and all that magic, but kind of gameplay is not like your thing you're totally focused on, because in the end it's about graphics. So then you could put more emphasis on those ones, right? So we will ask you what you will put emphasis on. The reason I'm telling you that now is that you can angle your efforts into that direction if you like, right? So if you say, we don't really favor any one of them, then they will be equally weighted. Yeah, so that's an option as well. It's a bit experimental as well. We want to try that out because that should balance up the different nature of the task that you'll be doing. Hopefully, that's the idea, right? But that's your input. You need to tell us which one you will favor. So the rest, no magic. So assignment repository, unlike the first assignment, you don't just fork something that's given. You just create your own repository in GitLab and link it on that group allocations page. So we have access to it, obviously access to it, to your peers and the instructors ideally. If you do Pacman, the original grid is still in the first assignment repository, so you can just extract it from there and use it. You obviously need to invent a third dimension, right? So because it's actually just two-dimensional, surprise, surprise. So that's something you need to come up with, yeah, probably won't challenge you too much. But that's pretty much there. Submission as before, right? You have your repo, and at the deadline it's considered stable-ish, right? So yeah, no more commits afterwards, or well, so that's the kind of idea, and then we assess it on that basis. Of course, the URL needs to be correct, group allocations need to be finalized by then, right? So in the table, and yeah, stuff should run. I mean, yeah, baseline understanding. It doesn't really make sense just to inspect code if nothing works. Of course, if there's some features that don't work, it's different from not compiling as expected. So that's our take on that one. Questions, ideas, or worries? Okay so far? Yeah. So anyway, you can look at it. It's on the main page link, or you can find it here as well, so you can think about it. If there are questions, or let me know. I'm happy to refine that. Yeah. So the only thing that I'll probably refine is that I want you guys to be explicit about external resources you use. Both in your README. Yeah, in your README mostly, right? So where did you get your model from, right? So or which libraries are you using? That's the kind of proper acknowledgement of external resources. That's the only thing I will add here. But other than that, I don't know. So yeah. So for the ones of you that actually want to go on the curiosity route, of course, come think about it. Take your time. I mean, but let's interact as early as possible. So both in terms for us, so we can plan a bit the course direction, but also for you to get started early somewhat, right? So if you have an idea by Monday or so on, would probably be helpful to discuss that and see if that's a good basis and you need to extend it, or if the scope is enough, right? Of course, we and you may not know the entire scope, so maybe some objectives you're setting out, you may not actually meet them, but if you can justify why you didn't, because you need to put a lot of work into something else, then it's a bit, then it's of course okay. In fact, this I think is a tad harder anyway than this one. The reason here is that there's a stronger research element than in the Pacman one, right? So Pacman one, most of the problems I think should be somewhat known or are very kind of clear what the individual challenges are here, right? Here's a lot more grounds for doing independent research as opposed to just program and implement it. So that there will be a challenge there, but we would encourage you to take it up. And the idea is there. We'll aim the outcomes so in a way that you shouldn't be disadvantaged for the final assignment, for the assignment exam. That's something we want to guarantee as well. So we need to keep that in mind as well. So it's quite important to talk to us about this as well. Cool. Anyway, I'll leave it there. You guys can inspect it and challenge that. Good. All right. So. What else do I want to say? No, that should be enough. That's cool. Okay, right. So last session, what did we do last session? Hang on, I wasn't here. The session before we did something. What did we do? All right. Good morning, everyone. This is graphics.
Were we still on file extensions?
Sorry, what?
Were we still on file?
Yes,
files,
we
or-
still talk, yeah, and then there were some interesting insights from the community. Trader Toy, right? Was it? Yes, that's right. So no, we were on file extensions and finishing up on X3D. We kind of reviewed briefly OBJ again. You know, there were some questions left. We covered that one. So you guys should have a reasonable, intuitive understanding of OBJ. One thing I'm super surprised about in this field, that specifications are really average. If you in New Zealand say average, it means bad. So never say average. How was your performance? Yeah, that's pretty average. So it means no, that wasn't good performance. And this is what I feel the reference specifications are in graphics for the OBJ format. The specification is not good. So, and we'll see that again for some other aspects later on. But what I want you guys to have is a basic understanding of how the OBJ formats works, how you load it, how you use it. And if, of course, you implement your own object loader, you will deal with the intricacies. It's actually quite straightforward to start implementing it, but it becomes relatively complicated once you look at material libraries as well, which are attached to it. So that's some of the aspects. So last session we looked at objects. And before we get to that one, to OpenSceneGraph, I just wanted to do talk about some terminology, because there were some questions regarding what, for example, meshes are and so on, right? So we had a bit of discussion, okay, what is that actually about? The terminology didn't seem to be really clear. And so I wanted to clear that up before we move into scene graphs, which relate back to objects. So if we talk about the structures that we're using for modeling, the baseline of everything is vertex, right? So, and depending on the graphics framework you're using 3 or more vertices to form some sort of face, right? 2 vertices is a line, 3 vertices is a face. Can also be more, but generally it's 3 of them to allow us the representation of 3-dimensional smooth surfaces, for example. And the question there was, okay, what elements are part of a mesh? And yeah, the answer is not quite straightforward. In fact, there are slightly different opinions on that one, but the probably most comprehensive overview is that mandatory elements of a mesh include the vertices, specification of the vertices, the edges, and the faces associated with it. And if you think about this right now, if you think back to the OBJ format, these were basically the ideas, the basic components that were specified there as well, right? So we had vertices, individual vertices. We had, what else did we have?
Normals.
Cool, yeah. And then?
Extra coordinates.
Extra coordinates. And finally? The last thing we need?
Smoothing groups.
No? Later on?
The indices for the...
Yes, what were they called? What's the prefix?
F.
Yes. What stand it for? What does it stand for?
Face.
Yes, right? Those are the faces. And that's precisely the kind of minimal elements that we need. And even in the OBJ format, there was a lot of optional stuff that goes on top of it. But those are the minimal elements. So vertices, including some or all of those, right? So color, normal, and texture coordinates. Edges.
I imagine if you don't read the normals of most files, you'll end up with some really weird effect where only a certain amount of the faces is actually rendered, because it might be random from whatever software rendered it, whether it's being listed clockwise or counterclockwise.
We get to that in a second. That's another problem. Yes, that's right. We get to that. That's correct. You actually screw yourself over. But this is one of the how to serialize meshes properly. Yeah, we talk about this. That's right. So normals, if provided. Edges, if we don't have a face representation, and faces, of course. And then in addition, you can have larger elements like polygons where individual faces are combined. For example, 2 triangles combined into some sort of rectangular representation and so on. And then surfaces and which is basically, in this world, corresponds to what you mentioned as smoothing group. So the idea of having a surface is a combination of multiple triangles, right, that represent some sort of surface, and the smoothing groups, for example, in OBJ, were used to calculate kind of an interpolated normal, right? As opposed to do it for each of the vertices or even triangles, you do it across the entire surface or smoothing group that you have. And of course, then there's, so this, from here on, basically from here onwards, this is, apart from the material right now, it's all about abstraction. Right, so here I have the individual faces, and then how do you group them together into one element? For example, the visor of the nanobot.
Nanosuit.
Nanosuit, sorry, thank you. How could I get that wrong? That's right, that's right. And how you group elements as well, right? So, you know, different elements of that suit, you know, that can be grouped together and so on. And on top of it, materials, which are, you'll see, in a sense, largely optional. That, for example, most of the free rendering tools actually don't really care about material modeling too much, I find. But again, so it really is kind of flexible, but there's some minimum requirements. So they should be represented in a mesh. So if we talk mesh, we think about those elements. One of the other aspects is the mesh. Yeah, even there's various definitions, but generally connected by one or more vertices. There can be cases where a mesh may also include non-connected triangles, right? So where they're actually separated, but they're treated as a coherent, you know, as an element, right? So for example, I don't know, what's a good example? A car tire that doesn't seem to be obviously connected to the, you know, body of the car, because, you know, there needs to be this element of movement, and there's no explicit link, but it's grouped together with this car object. This would also be considered a mesh, right? But generally, in most cases, it would be connected by one or more vertices, such as, you know, here in this very, across an edge or across a individual vertex. That's perfectly fine as well. Which is apparently not fine is this one here, right? You can't just connect an edge to a vertex, right? It needs to be vertex to vertex, and which may correspond into with linked edges. So it's one of the constraints that we have there. That needs to be borne in mind. Thoughts, questions? Okay, so it's basically the conceptual basis for any model that you make is a mesh, right? So complexity is, of course, not constrained here. So looking at the representation for meshes, and that comes closer to the direction you had in mind here. What's the preferable way of representing them? It's kind of given away there, but what does that mean then, at least? If you want to represent a mesh, and now you know the OBJ format, so what's the, or put it this way, why does the OBJ format represent the mesh the way it does?
You need the indices, you need to tell the indices which other indices it's connected to using the edges, and you need to tell which ones of the edges form a surface, and then you can explicitly state which part of the surface is up and down with the normals. Cool. But you don't have to.
Cool. Yep. That's fine. Yeah. So yeah, exactly. Yeah, you kind of line it up. There's, yeah, okay, just to provoke discussion. So why wouldn't I just redefine, for example, a vertex for each individual face without indices, but just by using coordinates? Right now you're suggesting, okay, we're having individual faces, right? So let's say, and this is 1, 2, 3. It probably needs to be 4 now here. So your point was, and that's obviously the answer, but the point was basically to define those vertices in terms of the indices that are associated with the actual coordinates, right? So
Well, how are you going to have normals without indices?
Okay, that's part of it. Let's ignore the normals. You're right.
Well, how are you going to have faces without indices?
Well, the idea was there. Couldn't I just list all the individual components in a long list of floats, basically, right? So where you specify coordinate 1, 2, 3, coordinates.
So you have 4 trillion separate objects floating in space that just happens to represent the model.
Nice, nice. Yes. So what's the problem with that?
We'll say.
Well, then she had the coordinates, right? So separate is a matter of perspective, right? So, but no, your point is good. Just continue.
Yeah, I mean, just if it's really, really big, you'll get floating point precision errors,
Exactly.
and every face in the model start to jiggle around.
So that's one of the aspects. Earlier, when we talked about textures, we talked about some. So first of all, there's an obvious efficiency element, right? So by having the reproduction of all the exact coordinates, right? So a lot of redundancy, redundant representation. But what was the other element? We talked about 2 different components in 2 different two different aspects of models. If we use coordinates, what are we referring to? What is that?
A vertice.
Sorry?
A vertice.
A vertice.
A vertice.
Okay. So now you have multiple vertices, and they are all combined together into some sort of shape thing, right? So if we use the coordinates, what are we representing?
A graph.
Yeah, well, in this case it's undirected, yeah, but it would be a graph kind of structure. Now what I want to get is like geometry, right? So it's a geometric object in which the absolute position in space matters, right? So we talked about something else in addition to that one. Geometry, and the other thing was not so much where things are positioned in space, but you said it quite nicely, because you said now you have a large number of individual faces floating in space, and they happen to be very close to each other, or perhaps even very linked, so they appear as one, right? So what is that representing? Because geometrically they're still independent.
A mess.
Sorry?
A mess.
A mess, yeah, okay. Okay, if you were to say a mesh, I would be a bit more happy, but you'll be fine with it.
I mean, mesh also works, but I wouldn't call it a mesh when they're not actually connected to each other.
Yeah, but technically it's only a problem of representation, right? If you use the coordinates and just use a different representation system, have the same result, so you probably get away with this because you don't know how your dodgy graphics application internally, a modeling tool internally represents it. You would still accept it as a mesh, right? So
An object?
the object would be grouping. Now what I'm looking for is topology. So not so much where things are in space, but how they're connected. Right, so we talked about this briefly. For example, you have an underground system. You just know things are connected, but the actual geographic distance doesn't matter. Right, that's really separate, secondary concern. And using the idea of index face sets, have the coordinates separate from the indices that point to it, allows us to separate topology from geometry. Right, the absolute representation in space from the connectedness of the individual components that we have. That's one of the conceptual reasons why we can separate them. I just wanted to spell that out explicitly because I think it's quite now it's quite noticeable after we have talked about the OBJ format. It makes a bit more sense how those 2 components can be separated, right? So you can in your index face representation you can easily change any coordinate, but the topology won't change, right? Only if you start changing the pointers to coordinates, then the topology has changed. So it's also easily verifiable whether the topology has changed or the geometry has changed, right? So a topology change occurs if you need to reconnect something in a different way. A geometry change is independent of that one, just says how did something move in space, right? And in practice, you guys know OBJ format, you have a area of vertices and then some sort of indices that point to those ones. And one of them is the separation of those ones. Another reason which you implied is, what was the other reason for using this index face set representation?
Performance, file size.
Yeah. So that's precisely it, right? So the efficiency increases. In fact, if you have a edge-connected mesh, then you approximate the introduction of one additional vertex per triangle, right? Which is like super efficient, plus plus reference. So it's actually quite efficient.
Or actually a question though.
Yep.
Dropping the indices, so that's spare enough space to make up for the additional vertices you have to define?
Yes, question to the class, does it?
No way.
Does it? Or under what conditions would you think it does?
Is it?
Is it? Sorry, internal humor. I mean, you're exchanging a line of code for another line of code. I mean information, I guess.
Yeah, but what are you capitalizing on?
Reusing?
Yes, right? So you reuse a lot of stuff, and the coordinate representation is a bit larger, right? So then a vertex representation, then an index, right, to it, right? So this is an integer representation point to one vertex, which consists of a number of components, right? So at least 3 anyway, plus whatever else you have there. I don't know how to texture code.
I mean, if you have more than 1,000. No, okay, I get it.
So that's smaller, so you can reuse. What was the other advantage is, I lost it right now.
Performance?
Performance, right, yes. And yes, you can use a non-floating point representation for indices as opposed to floating points for the coordinates. So you're safe on that one as well. That's the other one. So it's performance, but actually generally the more important one is deemed this one. Because if you have modeling tools, you want to differentiate between geometry, orientation, and the topology. But in practice, it's always done exactly the way you say. And you save massively because of the reuse, smaller data representation, not only, smaller data representation, low redundancy, and simple indexing based on integer types. So where permissible. But of course, if you want to argue that point, you could argue, okay, it's slightly better if you have a mesh that is disconnected, right? So we don't have the benefit of reusing vertices. Then you can benefit from having a pure vertex representation, right? Because the indices don't have any, you don't have shared coordinates, right? So then you obviously would have some gain. So the larger your mesh gets, the greater the gain of using that mechanism. Okay, now the other thing, and again you mentioned it, sorry guys, a bit theory thing, but I'm just filling up gaps of stuff I probably should have talked about before, but all of it makes a bit more sense after we have talked about OBJ now. The other thing was orientation. You just mentioned normals, right? So, okay, we need to have a normal specification to know the orientation. And the orientation is basically, when we talk about orientation in meshes, we're talking about the order, that's quite important, in which the vertices are specified. And the important bit is there that this representation is consistent, right? So either we're consistently counterclockwise in the specification of our vertices. I think I got that right. Yes, I did think I did. As opposed to in this one, right? So those two ones are considered, the empirical representation is considered incompatible because one is specified counterclockwise, right? So you use that to identify normal, the other one is clockwise, right? So in this case, it's not clearly orientable. It's not clear to the parsing software what the orientation of that of this mesh is, right? So the idea is there for parsing purpose or anything else, be consistent either way, but by default it's generally counterclockwise. That's the default one, but consistency is king, right? So yeah.
Does it really matter though, considering you have normal data?
Yes, if you have normal data, you're fine in principle, but it's super messy to parse that, right? So if you get a model that has varying orientations in the specification, you want to, if you write, for example, a parser, it's a lot more convenient to have a consistent conception, but also if you write a model, you want to be consistent. You want to have a consistent output, either counterclockwise or clockwise, but generally counterclockwise the way it's written. If the normal is not provided, the assumption should be counterclockwise reading of a vertex. So this is just about term here, right? So if you hear about Orientation, that's referring to that problem. Orientable, yeah, that's the one. It means they're all oriented the very same way, right? So if they're not, then they're deemed incompatible and the mesh is not orientable. All right. Cool, don't do that. Cool. Yeah, that was the one other thing. Again, geometry topology, right? Just put it out there again. We talked about it before, but again, geometry is really where things are in 3D space or 2D space or 4D space. I don't know. Anyone feels encouraged to do something 4D? Anyway, and topology is just about the connectedness, right? So indices, right? How vertices are linked up. And if you need to change the connections of individual vertices, then you have a change in topology. If you change the position in space, you change geometry, but not necessarily topology. Cool. With this, I'll probably give you a few minutes break because you seem to be dying. Some of you. I think some of you didn't make it. All right.
No, that's just a default state.
A default state, okay. Okay, I give you a break of 5 minutes and I carry anyone out who's still, who didn't make it. Cool, so then we continue about talking about scene graphs briefly because it links quite neatly into that problem. So 11:15 we continue.